Hello, welcome back to our channel. Today we are going to discuss about how to use the integration concept in physics. So we are using many number of integrations in physics, especially in the case of work done, in the case of from acceleration to velocity, from velocity to displacement, we are using the integration topic. For doing the integration, we must know about these formulas. Look here, integration of x to the power of n into dx formula is x to the power of n plus 1 by n plus 1 plus constant. This constant, no, most of the time we are using, but this is the actual formula here. Like that here constant came. So constant we are writing as usual outside 4 times of this x to the power of n plus 1 by n plus 1 plus constant. Like that here integration of 7 into dx. Just I have given the example for this one. But instead of this you can take any number. Just you remember that this is the constant. Constant into here integration differentiation cancel. You can get it 7 times of that x. Like that they have given as a function 2x square plus 3x plus 4. You should split this one. 2 into x cube by 3. Here 3 into x to the power of n plus 1 by n plus 1 means x square by 2 plus 4 times of this one 4x plus constant. Like that integration of 1 by x into dx formula is a log x. Integration of exponential function of x into dx is a e to the power of x plus constant. Then integration of sin x into dx, you remember this one, especially BPC students, here you are getting minus cos x plus constant. Here integration of cos x into dx is the sin x plus c. Like that we are using, suppose entire thing you should consider this is the t sin omega t plus phi into dt is the, we are getting minus cos omega t plus phi by, beside of this t, here this with respect to t we are doing, beside of t omega is there, so we are getting it is as a denominator. Like that when we are doing the cos function, you are getting this sin omega t plus phi by omega. And integration of ax plus b into dx, here with respect to x means here denominator a we are getting, beside of x a is there. But mostly we are using this formula. You should remember this formula and this, and this sin x and cos x also you should remember. Then where we are using in physics, I am explaining to you, listen carefully. In our motion in a straight line chapter, you know that rate of change of displacement is called the velocity, rate of change of velocity is called the acceleration. See, reverse we are doing, reverse of differentiation or derivation is called the integration. See, v equals to rate of change of displacement. When we are doing the cross multiplication, what we are getting, dx equals to integration of v dt. So both the sides we are taking the integration. Here integration differentiation cancel. X equals to how much? Integration of v dt. Suppose starting time is the t1 seconds and ending time is the t2 seconds, means we can take the limitations also this one. We do one problem here. Suppose if v equals to 4x cube plus 3x square plus 2 4t square, we are t cube 3t square plus 2. Then how to find out the displacement here? Just now we know that x equals to integration of v dt. So integration of 4 we are writing outside, t cube into dt plus 3 into integration of t square into dt plus integration of 2 is outside, we are writing dt. So constants we can't apply the derivatives and integrations both. So here suppose t1 equals to 1 second and t2 equals to 2 seconds. So limitations are 1 to 2. Here also 1 to 2. Here also 1 to 2. So x equals to how much? 4 into, this formula is what? T to the power of 4 by 4n. T to the power of n plus 1 by n plus 1. Limitations are 1 to 2. Plus 3 equals to 3 into t cube by 3. Limitations are 1 to 2. Plus 2 into integration differentiation cancel, we are getting t here. Limitations are 1 to 2 you are getting. So like that, after that this 4 cancel, 3 cancel. X equals to, see, instead of t, first we should apply the upper limit. Here upper limit is how much? 2. So we should write it 2 to the power of 4 minus lower limit is the 1. Instead of t we are writing 1 to the power of 4. Then instead of t, here we are writing 2 cube minus 1 cube plus 2 into, instead of t we are writing 2, then minus 1. After simplification, we are getting the displacement. X equals to how much? 16 minus 1 is the 15. 15 plus here 8 minus 1 is the 7. And this is how much? Plus 2. So x equals to how much? 24 meters. See, when we know we are doing the rate of change of displacement, derivation of displacement is giving the velocity, then integration of velocity is giving the displacement. For doing the integration, we must know about the basic formulas, then only you can able to do this one. Not only this one, see, we know that velocity equals to acceleration equals to rate of change of velocity. When you know the velocity, how to find out the acceleration here? Rate of change of velocity is the acceleration. Suppose you know the acceleration, how to find out the velocity? Integration of a dt. If they are giving the limits t1 to t2, like that you can take it. So this is belongs to motion in a straight line chapter. Like that, in the case of work energy power, what is the work done formula? You know that dW equals to force into displacement when theta is 0 degrees, because cos 0 equals to 1. So for finding the entire system work done, what we are doing, both the sides we should take the integration, f into dx. Here integration differentiation cancel. Suppose f equals to 3x square plus 4x plus 7. Then how to find out the work done here? See, integration of 3x square plus 4x plus 7 into dx. After doing simplification, work done is how much? 3x cube by 3 plus 4x square by 2 plus 7x. So here 3 cancel, 2 2. Finally we are getting the work function in terms of the displacement only, x cube plus 2x square plus 7x. Like that we can find out the work done. Like that many cases we are using in the case of thermodynamics also. What is the work done formula in thermodynamics? dW equals to pressure into change in volume. dW equals to pressure into change in volume. So for finding the work done of entire system, both the sides we can take the integration. Integration differentiation cancel, work done equals to, here lower starting volume is the V1 and ending volume is the V2. We are writing P into dV. P into dV. Suppose here work done equals to, if you know the P in terms of volume function, simply we can do this one. Otherwise, suppose P equals to 3 V square plus 2V plus 6, and V1 equals to 4 and V2 equals to 2. Then how to do this one? See, 1 to 2 V square plus 2V plus 6, we have to do the integration. So then what is the formula? This is the V cube by 3. Limitations are 1 to 2. Then this is V square by 2. Limitations are 1 to 2. Then 6 times of that V, 1 to 2. After simplification, what we are getting here? 1 by 3 into, instead of V cube, 2 cube means 8 minus 1 cube is the 1. Here 2 cancel, you are getting 4 minus 1. Here 6 into 2 minus 1. So after simplification, you are getting the work done also. This is how much? 7 by 3 plus 3 plus 6. After taking LCM, you can do remaining simplification. 7 plus here 9 plus 18. So finally you are getting 15 plus 9 is the 24 by 3. Answer is how much? 8 joules. So when you know this pressure, you can do the integration with respect to volume, then we can able to find out the work done. Not only this case, whenever that we know that concept, we can able to find out this one. In the case of electric potential and capacitance, one more example I am giving to you. Electric potential and capacitance, you know the relation between intensity and electric potential is E equals to dV by dr. E equals to dV by dr minus here. Then while doing the cross multiplication and we are getting dV equals to, it should be right E bar dot dr bar also. If theta is 0 degrees, cos 0 equals to 1, and both the sides we are taking integration. What we are getting here, V belongs to potential. So minus integration of dr. Suppose r1 equals to 1 meter and r2 equals to 3 meters, like that we are taking. And E they have given that 4r square, otherwise 4r cube plus 2r plus 3. This is the E function. Then how to find out the potential? We are getting minus here, instead of E, 4r cube plus 2r plus 3 into dr. After same thing, but based on the situation. Here in terms of work done, that is in terms the displacement they have given. Here also intensity and potential they have given starting and ending positions R1 and R2. That's why we have taken here, this is the lower position, lower limit, and this is the upper limit. Look here, V equals to minus 4 into R cube by 4 plus 2 into R square by 2 plus 3R. But what are the limitations are here? 1 to 2. Here also 1 to 2. This one cancel, this 4 cancel. Then this is minus r cube, 1 to 2. 8 minus 1 cube means 1 only. Plus 2 square is the 4 minus 1. Plus 3 into, instead of this you are writing 2 minus 1. So finally V equals to what you are getting, 7 plus 3 plus 3. Answer is minus 30 volts. Like that we can, if you know the intensity, we can able to find out the electric potential with the help of the integration concept. So most of the cases we are using this one. In the case of electric potential, in the case of intensity, from velocity to displacement, when you know the acceleration, we can able to find out the velocity. From the velocity we can able to find out the displacement also. Thank you everyone. Please subscribe my channel.